All right, it's Miss Garcia coming at you. Today we are going to learn about two-factor Punnett squares. Another name for that is called a dihybrid cross. Basically, that's where you would look at two traits at the same time. So if you look at these parents down here, these are two different parents' genotypes. And what we're seeing is that both the parents' phenotype is that they have brown eyes and that they're tall. So we're looking at height and eye color at the same time. So if you do a dihybrid cross, you'd be able to find out probabilities of what are the chances that they would have both brown eyes and tall stature. What's the probability they'd have green eyes and be short? If we did a dihybrid cross or a two-factor Punnett square the old school way, we'd end up with a Punnett square with 16 possibilities and 16 boxes. But I'm going to simplify that for you, and we're going to do something called the cheater's method that I think that you'll find a lot easier. So the first thing we're going to do is we're going to separate out the two traits. So what I mean by that is that we're going to make a Punnett square for our eye color, which is what I'm highlighting here, and then we're going to make a Punnett square for our height. Okay, so I'm going to separate and draw I'm going to move my B's down here. So it's like if one parent is heterozygous and the other parent is heterozygous for brown eyes as well. Okay, now I'm going to move my plant height and make a cross for that as well. So I grab my T's for height. Okay, so basically now we have genotypes for each, and we're going to run two Punnett squares, one for each trait. So I'm going to move this down here. Cross it out. Okay. Now I'm going to make the Punnett square for my plant height. Excellent. So now we're ready to answer some questions about this, starting with the phenotypic ratio. So if you see below, it wants to know what the phenotypic ratio is. So basically, how many will show up with the dominant physical appearance versus how many will show up with the dominant physical appearance for plant height? How many will show up with the dominant physical appearance for eye color versus how many will show up with the recessive plant height? So for this, all we have to do is count up our numbers and do a little bit of simple multiplication. So here's what I mean by that. So in the first Punnett, for eye color, how many show up with the dominant trait? That means how many show up at least with one capital B? That's 1, 2, 3. So we're going to write underneath here 3. And on our other square, how many show up with the dominant trait over there? That's 1, 2, 3. So we're going to multiply 3 times 3, and that will give you 9. Okay. How many show up with the dominant trait in this square? So again, that's 1, 2, 3. Versus how many show up with the recessive trait in this square? That's only 1. So 3 times 1 is 3. Okay. How many will show up with the recessive trait from this crossover here? That's only 1. Times how many show up with the dominant trait, so dominant on this side, and that's 1, 2, 3. 1 times 3 is 3. Last one, how many show up recessive from this square? That's 1, times how many show up recessive from plant height square? That's 1, so 1 times 1 is 1. Okay, another fun fact, if you want to double check yourself, this number right here, the ratio should always add up to 16 because there's 16 possibilities in a dihybrid or two-factor Punnett square. All right, next, let's try to answer some questions about the offspring. So this question asks, what's the probability that the offspring will be heterozygous for both traits? So if you were heterozygous for eye color, your genotype would be this, right? If you were heterozygous for plant height, this would be your genotype. So we're going to go see, since this is probability, out of 4 from each square, who would contain those heterozygous genotypes. So looking above, we're seeing how many from this square, how many from above have the heterozygous genotype. That's 1, 2 out of 4. So we're going to write 2 out of 4. Now we're going to multiply that by how many are heterozygous for plant height up here, which is 1, 2 out of 4. So 2 out of 4. 2 times 2 is 4. 4 times 4 is 16, and then you can even reduce that. 1/4 would have a probability of having, both have a 1/4 chance of being heterozygous for both traits. Okay, so let's try another one. What's the probability the offspring will be short with green eyes? So what's the probability the offspring will be short with green eyes? So their genotypes would be short was 2 lowercase t's,